Today, what I would be covering is in terms of a brief overview of what confidential computing is and how and different options do we have in terms of confidential computing and how uh, one of the ways we can use OpenStack to orchestrate some of the workloads that can be run within a non-confidential computing enclave. So that's what I would be covering with a specific demo as well. So to just give a quick information of the speakers, myself and my colleague Divya K. Kunur had kind of provided this bio, this particular speaker topic for today. Divya is a senior technical staff member. We both are part of IBM. She is a senior technical staff member and specifically leads the confidential computing offerings like HyperProtect crypto services, HyperProtect virtual services, and crypto appliances. And I am Srirama Sharma. I am the senior technical staff member in IBM working on Z Systems, specifically as a product owner for IBM Cloud Infrastructure Center, which is kind of built on top of OpenStack and provides infrastructure as a service on IBM Z Systems and Linux One, which is mainframe-based systems. So to quickly get started on what topic do we have today is what is confidential computing. So if we look at the big picture, confidential computing is the protection of data in use while performing computation or using that particular data for your computation in a hardware-based enclave, which is supported with trusted encryption or trusted execution environment, which is running in a trusted execution environment. So while we talk about data in use, which is being used for the computation, it is secured in that particular enclave. So if you look at some of the different scenarios, here the data protection at rest is taken care of using encryption and crypto libraries where you can encrypt and decrypt data which is at rest. Data during transit is also kind of taken care of using TLS and some of the other transport layer services which provide security for data in transit. But primarily what confidential computing looks at is how do we ensure the data which is being used and processed during by the application during the computation or any other consumption is kind of kept secure. Again, a little bit detail in terms of how it is about protecting data in use. If you look at data in transit, we do have the data that is starting from endpoints to the computational VMs or vice versa. So this data that is being transmitted through the network is kind of secured through end-to-end encryption. Primarily, TLS is one of the options that is used. And on the right-hand side, if you look at the data at rest, which means I do have the data which is already stored and is on the storage, but somebody could access the storage and use it, and that's where we make use of data encryption on the device itself. It could be at the data set level, or it could be at the storage volume level, or it could be at the physical device level. But the main paradigm of confidential computing comes in when we want to secure that data while it is being consumed in the virtual machine or application itself. And there are multiple threats that it could impose where in terms of memory attacks, people can take a snapshot of your running VM and be able to access the data which is being computed. In the same way, hypervisor-based attacks can also happen. And insider threats where somebody who has access to that particular compute VM where the data is getting churned out can also take a snapshot or probably have access to the file system of it and leverage it. So there are multiple such issues that are security threats that could arise, and hence we are looking at confidential computing. In terms of why, again, there are three major aspects in terms of having confidential computing. One is the security of the data, and in some of the industries, say for example banking or credit card usage and so on, or wherever there is an SPI data is being used, personal information data is being used, that becomes a compliance directive from any federal agency or regulatory bodies and so on. So that is another reason. And also in terms of controlling the access to the data, in terms of how do I ensure control of the access to the data. One, we will just go through it in detail now. So if you look at protecting data from the security point of view, there are multiple types of data, right? So in the public data and also the internal, and those data can also be classified as confidential and sensitive. The data which is public is something which you don't need to invest more on securing it, because it's anyway public and people are okay to access it, and that's how it is classified. And some of it is which is internal is still okay with respect to the within the organization or in the within the realm of the organization where we are consuming it. The criticality comes in terms of confidential data and how do you secure sensitive data. And if you look at, there are two ways. One, yes, everybody believes me, and I assure you that yes, it is not being looked at, so it is secure. So that's kind of operational assurance. So suppose if I am a on-prem system, and the system administrator who is taking care of the VM on which you are loading data and processing it assures you saying, I'm not looking into the data, it is just given to you, this is the asset. I do have access to it, but I'm not looking into it. So that's kind of an operational assurance. It could be through an SLO or SLA, or could be bound through the legal aspects as well. And when we take it to the hybrid cloud point of view, this is one of the operational assurance that is given. And second way is to provide technical assurance. When I say technical assurance, in addition to the operational assurance that I provide that I am not able to access, I will not access, it technically also constrains the person not to access it. So the technology which is being used kind of limits him out from accessing that particular data. So if you just look at the way how at the bottom of the stack, how we are trying to put it is cloud infrastructure operator can also access the data and application, and customer can also validate and also access the data. However, on the cloud confidential computing side, where the confidential and sensitive data is included, the infra operator cannot access the data at all. So that's the technical way of limiting him from getting access to the data and applications. If you look at the second aspect of why confidential computing, mainly from the compliance point of view, as I mentioned earlier, the increasing regulations and the norms that are coming in from the regulatory bodies and financial institutions, that becomes a clear requirement for protecting the data. So if you look at from the inflection point in terms of how the data sovereignty need to be maintained, earlier it used to be mostly at the data at rest, focused on data at rest, where the regulatory bodies used to provide saying this data need to be secured and encrypted and also archived for certain duration of time, and even at the archival it needs to be secure and so on. But now, as in when we see there are multiple folks who could work as hackers and try to get access to data, because data is the key resource in the IT area. So, and modernization and digitization has also put up more challenges in terms of how do you secure this data as well. And hence, the regulatory bodies will also include specific requirement that the data in memory should also be encrypted, and also in terms of data during the compute, nobody should be able to catch hold of the registered contents and then be able to decipher from the same as well. So that's another requirement. And if we look at it from the control point of view, it's more from the different personas who would be accessing the data. One is the workload developer or a solution provider. He will have access to the data as well. And at the same time, environmental operator, SRE, who could also have access to the data. There is a separate limit or constraints that we need to set for them. And auditor or security, privacy data, or the government agency itself need to have access to the data as well. So how do we streamline or control each of these personas to have their own specific set of access and not be having more access than what they require for their performing their particular role is also a key aspect. So if you just look at what are the different technologies do we already have in the market, from the AMD point of view, we do have heard about AMD ACV capability, which protects the entire virtual machine itself. So the entire virtual machine where the computation is happening is kind of protected. And this is per VM encryption by making use of specific keys. And the isolation is at the VM level. Similarly, if we go look at Intel SGX, there the production of the specific portion of code is taken care of within the VM. The code is running in a secure enclave, and SGX creates a isolated memory region within the hardware, and that's the hardware support that it provides. So the other option or the technology that I would like to talk about today is in terms of the IBM secure execution. This is the protection of virtual machine as well as protection of the data which is running within the VM as well. So just by protecting the virtual machine, even there we could have specific chances where the operator who has specific access to go within the address space of the VM can also encache specific data that is being computed. With secure execution, it provides a hardware level encryption, an ultravisor, which will be made use of to first secure the VM and also encrypt the workload running within it as well. So here the trusted computing stack or the software, if you just look at it, I would specifically, if you look at from the malicious workload, can also be running alongside KVM guest, and the machine data can be modified. So specifically, the way how it is taken care of is Z15 and onwards. That's the hardware capability built in from that specific release onwards, where the KVM host can be booted up with an encrypted way using secure execution, and that can be done using the encryption keys, which only has whoever only has access to the boot device or the boot file for that VM will be able to bring that up. And also inside that we have a secure guest that gets created where the boot data is also secure using an encryption key. So whenever I'm trying to bring up a particular VM, I will need to key in that particular environment as a key in the encryption key as an environment variable for it to boot up and be able to access. And rest of the SSH and other access are also kind of taken off. So how is it implemented is in terms of the protected guest state is achieved using an ultravisor, where we have a different ultravisor table which is having guest specific memory access, which is saved across and not shared with any other guests which are running on the same environment. So how do we kind of secure that particular guest is, as you can see on the left-hand side, the container image provider will have their own OCI-based images that can be built using a secure build process, and that gets deployed on a secure guest environment, and wherever there are workload provider persona has access to it, they need to provide workload specification properties, and that is kind of encrypted by their own keys. And the environment owners in terms of workload deployer, they should also be able to use their attestation keys to boot up that particular VM or the workload. So that way, each of the workload data as well as the VM itself is both secure and kind of confidentiality of the data is taken care of. So how do we look at it? I mean, say for example, in this scenario, we have a hardware layer where we have the guest state that can be whoever is having hardware operational access can take a snapshot or take the guest state of the KVM which is running the Linux LPAR, and at the same way, the one who has access to KVM hypervisor with those privileges can take a snapshot of a VM that is running and thereby be able to access the guest memory as well. And of course, whoever is able to access the VM services itself, with UID root process, they can directly access the guest memory too. So these are different ways how the data in use can be kind of attacked. But the moment with the secure execution concept that I referred to. Here at the hardware level, we do through the ultravisor, the guest state is kind of secured. So any access from the hypervisor state or the system administrator to take a snapshot of the same will be redirected back, or it will be thrown out with an error. And in the same way, the second use case in terms of getting the guest memory access through the KVM or through privileged root process or user IDs are also kind of taken care of. So what it does is protection against malicious operators, the system operators. At the same time, it also protects against malicious hypervisors, and it also protects against bugs in the hypervisor which can be leveraged by somebody else who can use those open bugs for hacking. And if we just move on, where to leverage this particular confidential computing. So we just looked at confidential computing and what is the technologies to achieve confidential computing in terms of where exactly we can use it. So one of the use cases, as you were rightly pointing, in terms of digital assets, could be NIFTs or policy platforms, and also secure AI, where the models need to be, and the data which is fed to the models need to be secure. So that way there is no manipulation of the data at the time of consumption by the model itself, or at the time of inference through the model. And the same way, the security and privacy for data in use workloads, wherever the special privileged data needs to be taken care of. So these are some of the use cases where we can leverage confidential computing. So with this, the next step is in terms of how do I easily orchestrate VMs of capability that I talked about, which can be secure and encrypted, and at the same time, how can I deploy workloads on top of those VMs after I create it on the underlying infrastructure. That becomes a next level of kind of problem for operators in terms of how do we manage this. So for that manageability, what we can do is OpenStack. We have done some changes to the OpenStack at the libvirt provider within the OpenStack to understand and recognize the secure execution capability which is there in the hardware and leverage the same in the OpenStack UI. So if you look at on the, there is a software bundle called HPVS, HyperProtect Virtual Services, which gets deployed on an image or an LPAR. Here at the, okay, this is seen. Here, this is the hardware layer where we can have the feature code of the firmware that can be used to create specific LPARs or hypervisors or hosts. And on top of that, we have Cube libvirt driver, which has been enabled for secure execution, which is provided by the underlying hardware. And using that, we can create non-AC based environments as well as AC based environments. So it's not required that everything that is running on top of this needs to be enabled through secure execution itself. And all of these are encrypted through keys, and we can achieve confidential computing VMs and deployment of the same as a software bundle using the OpenStack. And this does support for Ubuntu, SLES, and RHEL enterprise Linux images, and also the admin users can enable or disable SE encryption based on and at the time of creating the VM or orchestrating the deployment of the workload. So the point I would like to highlight here is this is not comprehensive list of changes that we have done, but there are certain changes that have been included in libvirt to understand the hardware capability and also be able to recognize leverage those capabilities as well. So one of the use flow is as an ICIC stands for IBM Cloud Infrastructure Center, which is an open source, OpenStack based IaaS solution that IBM has. It can even be OpenStack with the changes that we have and that we are planning to contribute back to the community as well. So the OpenStack can leverage the AC capability with this particular user. Say for example, as a customer, I would just need to input the KVM host keys and the base image that I have captured, which is used from a secure build process. And this has to be done on a secure execution enabled Linux image. I build the same, and that gets deployed or through the CIC for creating the specific image and then deploying it onto the virtual machine or LPAR, which is created through the OpenStack driver. So, which means in the UI, I will be taking you guys through the specific demo here as well. So in the UI, I will have an option to select KVM as an hypervisor, and once the save KVM is selected, there is a check button using which I can ensure if it is a secure, if this VM that is going to get created or host, that is KVM host that is getting added, requires secure execution capabilities or not. So once I have secure execution enabled, the host that is created will showcase that it has secure execution capability enabled, and any VMs that can be created on this can have a deployment of the VMs which are built through the secure build process. So the next is, how do we take care of the secure image? So the OpenStack also has support for GLANs, where I can store the QCOW2 based images which are built using secure build process. So while creation of the image itself, I can specify the different, the hypervisor type, as well as the flavor of Linux that I'm using, the distro of the Linux, and if I need to turn this on or not. So using this way, I can create a secure image which can then be deployed on VMs which are created, or hosts that are created with secure execution enabled. And the third part is, of course, the provisioning part. As I said, the image gets provisioned on top of the VM, which is also enabled with secure execution. So that way, so the workload where your service is running is also built using secure build process with an encryption key, and where it is getting deployed is also a secure KVM host, where both of these leveraging the underlying IBM secure execution, which is the hardware capability, and the way how the workload is deployed on the virtual machine is completely confidential. So let me quickly start on with the demo. Okay. Or should I mirror it once again? Let me just mirror. Okay. So this is the OpenStack based implementation of infrastructure solution layer that we have. I do log into this particular IAS software using the credentials that I have, the management credentials. And here, if we just look at it, just shows the details of different virtual machines that are running. And these virtual machines are running on multiple different hosts, different type of hypervisors. It could be KVM, which is Linux KVM libvirt based hypervisor, or it could even be ZVM, which is proprietary IBM Z hypervisor. And we also have details about different volumes and the storage providers that are configured, using which I am configuring, which are connected to my Cinder environment. This also showcases the resource usage of each of those VMs. And now if I just go look at the management node, so this is the management node, which is nothing but the OpenStack management node, which is a single node deployment instance that we have done. And in this, we also, if we just go to the host side, we see there are multiple hosts that are available already, and I can create specific set of hosts as well. Here in this add host, as I showed in the screenshot earlier, I have option to select any of the hypervisor. In this case, I'm selecting the KVM hypervisor and will be keying in data in terms of host name, or the IP address and the user ID that needs to be used for the host name, and the display name for that particular host, the KVM host, and the password for that particular KVM host also needs to be enabled with a specific name of the interface. And this is the point where I will be enabling or using the checkpoint checkbox. By selecting the checkbox, I will ensure that this KVM host need to be of the type secure execution. And of course, this if I have to enable this option for KVM, this has to be on a specific hardware type which supports it. Say, for example, if SGX is supported by Intel based, only on those systems we can leverage SGX here. Z14 onwards or C15 onwards can leverage secure execution. Z14 onwards, we can leverage secure execution. So now this particular instance of OS01E has been created, and here if you just look at, there are 3 different instances. One is the IA compute and OS006 and OS01E. The other 2 are secure execution enabled, while the first one is the normal KVM which is available and running in this particular environment managed by the OpenStack management node. And if I just click on the host and then look at it, the now let's look into the VM creation, image creation part. So at this point, I will create a new VM using the OpenStack APIs. The image name, I specify the OpenStack image name, and then select the hypervisor type, which is KVM, and the distribution to be rel9, and the image disk type to be SCSI, and the source to be file. And I will select a QCOW2 image, which I will be browsing and using it from my local desktop, which has already been created using secure build process that I explained earlier. And if you recollect here, I have again checkboxed that it is a secure environment, which means the image that I am creating now is an image which was built through the secure build process using the encryption key and the workload data which is deployed, and both of them kind of running in a specific VM. So once I create this image, I can see that it is listed in the OpenStack. 1 second. It's getting created. So once it is there, I will also need to look at the networking configuration. So there I had specified KVM flat network. So if I just look into that particular network details, we see only there are 3 machines. I can go into the subnet that is configured and ensure the IPs are all available and listed. And now going to the security groups, I need to ensure this particular subnet that was created is added to that security group as well. And specific ports are enabled. Here in this case, 8080 is something that I am enabling because it will, the workload that I am kind of, that I have built using secure build image is just an hello world program to showcase, which gets deployed on a HTTP server, and any access to that server will showcase the hello world as an output. It could even be any specific data or a PDF or a model as well as I explained earlier. So now the next step is for me is now I have the infrastructure which is secure execution enabled. I have created a KVM host using OpenStack which with secure execution option enabled. So these 2 are in line. I also have created an image which is built through secure build process. How do I deploy this onto this LPAR and boot it up? For that, I will need a boot device or a boot disk that needs to be created. So using OpenStack Cinder APIs, I will configure, the storage provider is already configured. So in this storage provider, I will now create a disk pool, a disk volume. And in this disk volume is, I already have a DS8K, IBM DS8K storage which is used, and a base template that I'm using. And now I will create a volume with name demo HPS ICIC boot. And this is of size 100. And I will mark this as a bootable volume. So this bootable volume can be deployed. So only when I create this bootable volume and install it on a secure execution enable and the encryption keys match, it gets booted up. So I will select the image that was created earlier, which is HPVS stage, and then use that image onto the boot volume. So it just creates an volume now, and now I can click on deploy to deploy that particular image into that into the secure VM which was created. So when I say deploy, the VM instance gets created. I can select a specific deploy target, which is OS 006 that I had created, and the compute compute template can also be of any size. If you just saw that, I can specify the different sizes, which are t-shirt sizes, which can be configured as well in OpenStack. And once I deploy, I will need to assign now the network that I created, which is the IBM default network, KVM flat DHCP, and again the default security group. And here, this is the case, this is the specific point where I need to enter the configurational script. So this is exactly where I will provide the public keys of the workload. The whoever has developed that particular application will be able to give you this key. Only after you provide this key here and click on deploy, only then the deployment of the VM gets initiated. So this is the key, that image builder, whoever has built, the developer who has built the image, and now this deployment of that particular bootable volume is in progress. So I can keep checking on the status of the deployment using the console output, and once the console, what's happening is the secure image is getting booted up on the secure VM which was created. It's progressing further, and I can also check it in the logs on the status of the VM as well as the image, on what timestamp when it was deployed, and whether it is deployed in the same VM or so. And once it is complete, I will see a message that the VM and the workload is completely deployed. So this is the IP address of the VM service that is running on top of the secure KVM instance. Now if I just try to, I cannot access SSH to that particular VM to access the same. So only way how I could do is to do using curl. I can see it is I know it is a HTTP service. So I will try to access it through curl. And if I just feed it into JQ, I will see what the contents of that particular service are. What is it actually servicing? So here in this case, it's just outputting the result as hello world. Similarly, it could be any other particular, you are feeding in the data with an environment variable, and that performs the inference and then provides the inference output, inference of the data through the model and provide the result back to you. So this is a specific thing that I wanted to showcase as part of today's topic, and this is the demo as well, which I wanted to share it with you folks. If there are any questions or so, please do let me know. There are specific references also. I will be uploading it as part of the PDF on the Scale conference webpage, which can be downloaded later, and some of the documentation with respect to different references for the whole demo that we have built.